the last part of 7.3 is on the composition functions where you're not plugging in a value for the variable. We're just gonna leave it as a variable. I'm keeping this out because it can get a little ugly when you're looking through all the exponent properties. Okay, so we're gonna start with some of the same examples, and these are some very basic examples that we're gonna look at. Now, the way I'm gonna write out most of my problems are using notation f of g of x. Now, I like this because we can see that we're taking the function g and putting it into the function f. Okay, just like before we had the value, we plugged in the g, then we plugged in the f. Well, now there's no value to plug in the g. G already has an x there. So we're going to take g and plug it in the f. So really what we're doing is taking the f function and having something plugged into that x, which is what we did with the value before, but now it's going to be that g, which is x plus 3. We're taking that whole value and plugging it into that set of parentheses right there. So what we're going to have is 2 with our parentheses and then the x plus 3. I really think it's important to look at this and say, okay, I have the 2's being multiplied by the x. So the 2's outside the parentheses, and then inside that blank parentheses, we're putting the function g. And once you have that, now you just need to simplify. I'm going to distribute that 2, and we get 2x plus 6 is f of g of x. All right. Now going the other way with it, g of f of x. Okay? These are not going to be the same values, okay? Sometimes they will, but not always. This time we're taking the function f and plugging it in the g. Okay, so we're taking that x there and replacing it with the function f. Okay, so if you look at it again, just like how we kind of looked at this and wrote it out, same thing. We're going to have g, and then inside that x value, we're going to replace it with 2x. Okay, so what do we have here? The g is going to be something plus 3, and inside that something, we're going to put that 2x. Okay? And again, we're at this point where we'd simplify. Sometimes there's not going to be much to simplify. 2x plus 3, you can't combine those like terms, so it's just going to stay 2x plus 3, and that is our g of f of x. Okay, so that was going both ways. You can see f of g of x, 2x plus 6. G of f of x is 2x plus 3. They won't always be the same values of the same function once you simplify everything. Okay, so let's look at a couple more examples. Let's do one more basic one and then we'll do some harder ones. Here's the same function we had before in the last video. F of x is 2x plus 1. G of x is 3x. Starting with the f of g of x. Okay? So here's the f here. Okay? We have f, and we're going to plug in g, which is 3x. Okay? So looking at that, we're going to take 2 parentheses plus 1, and inside those parentheses, I'm putting that 3x. Okay? Now this way you have to take your time, simplify, and sometimes there's not much work to do, sometimes there's a lot of work. Here, it's 2 times 3x, that's a single term, so it's 2 times 3x is 6x. Just bring down the plus 1. And there's the simplified form. Going the other way, we have g of f of x. Okay, so let's look where that x is in g. We have a 3 on the outside. Okay, so we're going to have 3 parentheses, and now I'm going to plug in that f. The f is the 2x plus 1. So I'm plugging in 2x plus 1. I just skipped a step of writing out the g there, but now I think we're moving a little more just to see what you have to plug in. And now it's the distributive property. Distributive property should give you 6x plus 3. So again, you can see they're close to each other, they're similar, but not exact. Okay? See what the function is and where the value is going to go. And make sure, again, parentheses are extremely important. You have to follow the rules of the parentheses when you simplify some more complicated ones. Okay, so here we have f of x is 3x to the 4th. G of x is negative x to the 1/5. Okay, so we have f of g of x. So taking the g, plug it into f. Now this time, when I put parentheses around this x there in the f function, I really gotta look. Okay, there's a 3 that I'm multiplying by and a 4 that's an exponent. Okay, so let's look. There's f, and we're gonna see what we're gonna plug in there. We're gonna plug in negative 4 x to the 1/5. That's what's going inside those parentheses in our f function. So we have 3, empty set of parentheses to the 4th power, and inside we're going to put negative 4x to the 1/5. Now this is where you really need to take your time and remember your exponent properties, okay, as you're working through this. Remember, everything needs to be brought to the 4th power. We're also remembering order of operations. We're going to do exponents before we multiply that 3. Okay, so we're going to bring down that 3, and we're going to have 4 to the 4th power. Just checking my math here. Should be 256 x to the 4/5. Right? And now we can multiply 3 times 256, and again, it's single term there, so it's no distributive property. It's a single term, so 3 times 256 should be 768 x to the 4/5. So you will have to deal with some fractions in the exponents. Okay, you're going to have to deal with some negative signs and exponents. So just take your time when you're working through this. Okay, going through the other way, we're going to have g of f of x. So this time when I put parentheses in the g, take a second, look what we have. We have negative 4 on the outside on the left-hand side, and the exponent is 1/5. Okay? So g parentheses, and we're going to put 3x to the 4th, which some people might think this looks a little easier because that's a little nicer looking. So we're still have to deal with the 1/5, but I kind of agree. The 3x to the 4th is a little nicer looking to deal with. Okay? We're going to have negative 4, parentheses, 1/5 is the exponent, and let's plug in our 3x to the 4th. Okay? So there we have our problem. It's the same steps here. Okay? It's the same steps just with different values. We're going to first do the 1/5. Now, you will be allowed to give me decimals in this. I know 3 to the 1/5, I'm going to let you give me decimals in your answer. So take your time and plug it in. When you plug in that 3 to the 1/5, make sure you put that 1/5 in parentheses. Okay? It will make a difference depending on what calculator you have, so I strongly suggest using those parentheses. You should get 1.246 x to the 4/5. Let me just double check my math there real quick. Yep. And we still have that negative 4 on the outside. Okay? So now we have that negative 4, multiply it through, and we should get negative 4.984 x to the 4/5. So not the nicest looking answer. Watch your rounding, and again, make sure you're using those parentheses. I hope you're seeing how important parentheses are when you're plugging these in. Okay, so this one gets a little more complicated. We have that 1/5 as the exponent, which can gum things up a little bit, and we had to remember our exponent properties in order of operations. Now I want to do one more example. Okay, so we have f of x is x to the negative 3, g of x is 7x squared. So starting off, we have f of g of x. I'm going to move through this a little quicker, setting things up. Our f, and we're going to be plugging in the 7x squared. So let's look at our f. There's our f. It's x to the negative 3. So if I'm putting parentheses around there, the negative 3 is the only thing that's outside there. So I have parentheses, negative 3, and on the inside, 7x squared. Now, I'm going to allow you to give me two different answers for this. I said you're allowed to give me decimals. So if you want to go ahead and just bring everything to the negative 3 power, 7 to the negative 3, x would be to the negative 6 power, you're more than welcome to do that and plug that into your calculator. 7 to the negative 3 should give you 0.003, x to the negative 6. With the negative exponent, you do it to bring that to the denominator. And this isn't the nicest looking answer, but that's one answer I would allow you to give me for this problem. Another way, and probably the more way I would prefer you to do it, is dealing with the negative exponent first. Everything's brought to the negative 3, so I could rewrite this as 1 over 7x squared cubed. And now you just deal with everything in the denominator. Bring 7 to the positive 3rd power, and again, multiply those. And you should end up with 1 over 343x to the 6th. Okay? Both answers I would mark correct. I like the one without the decimals in the fraction a little better, but I would accept both those answers. Okay? Let's real quick do that last one then. G of f of x. This time we have that f of x is on be plugged in, so we're going to have g. Look where the parentheses are. We have 7 on the outside. We have the square. And we're going to plug in the x to the negative 3rd power. So if we set this all up, we should have 7 squared with those parentheses out there. And we have x to the negative 3. Now, 7's not in the parentheses. The only exponent we need to deal with is the negative 3 and the 2 here. Multiply those. 7x to the negative 6. Bring that x down to change that exponent positive, and there's your answer. Okay, so again, it gets a little more complicated. You're going to have to deal with some more decimals, some fractions. So you might want to go back and relook at these examples, follow the steps again. And you notice, I'm hoping you noticed, I did f of g of x and g of f of x for each one of these examples. Okay, there's not going to be many times I won't ask you to do both. And when we get to 7.4, when we start verifying if functions are inverses to each other, we're going to have to do both. So it's a good habit to get into. Just do the f of g of x, then the g of f of x. We'll have all the work down. It's also a good habit to get into labeling your work each time, showing me that this is f of g of x, this is the work for g of f of x. Stay nice and organized, and I can easily see, here's my work for the left-hand one, f of g of x. Here's my work for the one I did on the right, g of f of x.